Boom! No countdown, no delay. Instant power just like that. No valves to fail, no fuel lines to leak, just pure, unstoppable force. But what if you had to commit to a decision that, once ignited, couldn't be turned off? What if you had to design for perfection before the moment even begins? That's the reality of solid rocket motors. No second chances, just raw, calculated power. And today, we're diving into how these incredible engines have shaped everything from moon landings to missile defense, all because of their simplicity, reliability, and sheer explosive energy. Buckle up. All right, let's talk about solid rocket motors, the OGs of propulsion. No fancy fuel pumps, no cryogenic nightmares, just a big old tube packed with propellant, waiting to go boom. In a controlled and mission-appropriate way, of course. These engines have been around since the dawn of rocketry, and for good reason. They're simple, reliable, and always ready to fire at a moment's notice. Unlike their liquid-fueled cousins, which require an entire orchestra of pumps, valves, and cooling systems just to keep them from exploding too soon, solid rockets are the ultimate set-it-and-forget-it propulsion system. Once you light the fuse, there's no turning back, kind of like sending a text to your ex at 2 a.m. The burn is steady, the pressure builds, and the thrust generated is enough to punch through Earth's atmosphere like a wrecking ball through drywall. This makes them ideal for missions that require raw power, from military missiles to deep space probes. Their biggest flex? Simplicity. No moving parts in the combustion process means fewer points of failure, and that's why they've been a go-to for spacecraft in extreme conditions. But of course, there's a trade-off. No throttle, no stop button. Once it's lit, it's lit. Engineers have gotten creative with this limitation, tweaking the shape of the propellant to control the burn rate, but it's still not as flexible as liquid engines, which can be adjusted mid-flight. Even so, solid rockets have been the heavy lifters for decades. Just ask the Space Shuttle, whose twin solid rocket boosters each kicked out over 3 million pounds of thrust at launch. And NASA's still riding that wave with the Space Launch System, which is bringing solid propulsion back for deep space missions. The secret sauce? A cocktail of ammonium perchlorate, aluminum powder, and a polymer binder that keeps everything nice and stable until it's go time. But because humans love ruining things, environmental concerns around perchlorate pollution are pushing researchers to find greener alternatives. And then there's the hybrid approach, mixing solid fuel with a liquid or gaseous oxidizer for a bit of throttle control while keeping the storage benefits. Cool in theory, but tricky in practice, which is why hybrids haven't quite taken over. Still, solid rocket motors aren't going anywhere. From powering intercontinental ballistic missiles to launching deep space missions like New Horizons, these engines continue to prove their worth. Future innovations in materials like carbon fiber casings to reduce weight and new energetic nanomaterials for cleaner burns could make them even more efficient. Sure, reusable liquid engines are all the rage, but when you need something fast, powerful, and guaranteed to fire after sitting in storage for years, nothing beats a solid rocket. I'll leave you to discuss in the comments. Do you think solid rocket motors have a future in next-gen spaceflight, or are they slowly being replaced? Support us by subscribing if you haven't already. Take care of yourselves, take care of your loved ones, and I'll catch you soon in another video.